Learning target 3.13 says, I can determine molar ratios from a balanced chemical equation. So the example that I have here is looking at the one that we did in class. 2 slices of bread plus 1 jelly plus 1 peanut butter gives us 1 peanut butter and jelly sandwich. So again, these numbers, the large ones, are called the coefficients. And they kind of tell us how many moles of something are reacting compared to moles of something else. So we have 2 moles of bread reacting with 1 mole of jelly, reacting with 1 mole of peanut butter to produce 1 mole of peanut butter and jelly sandwiches. So we could actually write something called a molar ratio. So we know that for every 2 moles of bread, we produce 1 peanut butter and jelly sandwich. Or we could write a different molar ratio. Let's compare the reactants of 2 bread to 1 jelly. We know that for every 2 slices or 2 moles of bread, we are also going to react 1 mole of jelly. And again, we're comparing the coefficients here, the coefficients in front of our reactants and products. So I'm not going to write these down, but we could also say, for example, that for every 1 peanut butter we react, we produce 1 sandwich. Or for every 1 peanut butter that react, we're also going to react 1 jelly. So it's the ratio between the coefficients in front of our compounds. Now we can scroll down to this example, which you can still write in your notes. And we have aluminum sulfate reacting with barium chloride. And you can see we have coefficients here. We assume there is a 1. We see a 3, a 2, and a 3. So I want to write let's write 3 molar ratios. So let's compare how many moles of BaCl2 react to produce how many moles of AlCl3. So we know that for every 3 moles of BaCl2 that we react, we'll produce 2 moles of AlCl3. And we could flip these if we wanted to as well. Let's look at the ratio between this reactant and this product. We know that if we want to produce 3 moles of BaSO4, we will need 1 mole of Al2SO43. And then lastly, why don't we compare these 2 products? We see the ratio is 3 to 2. So we could say if we know that we produce 2 moles of AlCl3, we also must have produced 3 moles of BaSO4. So again, we're just taking the moles of each reactant and product, and we're using that as a comparison. So why don't you do this individual example, pause the video, and write down 2 correct molar ratios. Come back and check your work when you are done. So these are the 6 molar ratios that we could have written, and they also can all be reversed. So the key thing is to note that the coefficients in front of each compound represent how many moles there are of that compound reacting. So for every 4 moles of Al2O3 that react, we are also reacting 3 moles of SR. Or for every 4 moles of Al2O3 that react, we'll see 4 moles of Al2 will be produced, and so on. So make sure that your answers at least correspond to 2 of these correct options. We can also look at the ratio here in terms of the entire reaction. So you could probably predict that if we were to actually react 8 moles of Al2O3, we would produce 8 moles of Al2, since they have that 1-to-1 ratio. And if we double the moles of Al2O3 reacting, we'll also double the moles of Al2 being produced.